So to understand merge sort, we'll take our example array, and in this array we have 5 elements, and we'll give them indexes as we give indexes in an array. And now in merge sort, what we do is we use divide and conquer algorithm. That means first we will calculate the middle term of this whole array, which as you can see clearly see is 5. Then what we do is we will split the array in two parts. Now, since our mid value is 5, the mid index is 2, we can split either as 3, 2 as one single array and 5, 4, 1 as one single array, but the convention is to take the middle value if we have an odd number of elements with the first array. So first array will split would be this, that would form and here we'll have now we have split our original array into two sub-arrays. Now we will continue this method until a single element is reached, because single element cannot be splitted into more sub-arrays. So how will we split this? Now obviously the middle term is this. So very intuitively we can say that this will form two arrays like this. Okay, and this would be 3, and similarly here. But before moving on to this part of the array, as you would see in the code, when like programmatically when we start splitting the array, we first complete this section. We can choose if we want to complete this section first or this section first, but generally we take the left section first. We'll complete this section first. Even in the recursion call stack, we'll be finishing off this section first, the left side. So we'll be finishing the left side here. Now this would split into, and we know this cannot be splitted further, so it will be, so we have splitted the left side completely. Now then when we will like now then what will happen is programmatically first we'll be moving in this direction, right? Then we will move towards this side. In here this would simply split into two arrays like this. Now we will code this part. We'll implement our function in which we split the subarrays. Now we'll take in three arguments, the array which we have to split further, and its left and right value, because we need the left and the right values to calculate the middle point. Here also we will be needing the left and the right values so we can calculate the middle point and split accordingly. So it's important that in that sense. Now as you can see, since we are doing this splitting function like until we reach a single array, so this is a recursive call. Now in recursive call it's necessary to have a base condition, and in our case, as we know that when the left equals the right, basic that would mean when we have a single element, then we just have to return, basically we have to stop our recursion when we reach a stage where we only have single element, which it would mean that the left is equal to its right. Now we'll calculate our mid value around which we'll split, and it's obviously the mid can be easily calculated by left plus right divided by 2, and we just wrap it around math.flow, so it returns as an integer, even if it's if it basically it returns as an integer. Then we'll call our recursive calls of function. First we'll be sorting the first half of the array. We'll give the array, and the left is the left value till the mid, which would be the first half of the array, and then we'll sort mid plus 1, the second half of the array, right. As you can see here, if this is 0, like this is our left value, and this is our right value, and this is our mid value. So left till mid would give us this part of the array, right? And for the next part, we will have mid plus 1 till right. Since mid plus 1 will begin from here, and this will be our second part of the array. Hopefully it makes sense. And then we will do our merge function. We'll call our merge function here. We'll implement it first after we understand what is actually going on in the merge part of the merge sort algorithm. So first we need to split, and then we'll call the merge function to merge the array back up to the sorted state. Now this is our array tree that we have, and will merge will start from the bottom, obviously, because when we'll be finishing splitting we'll be here. So it will merge it back here to a sorted form, then it will merge this stage back to here to its sorted form, and then it will merge this whole back to the original array. Now how this function will work is a simple idea. Basically it will have two pointers, let's say I and j, pointed to each part of the array. Now since these are all single element array, so it will be easier. So what it will do, it will compare these two. Now which one, like compare the first part of the first array to the first element of the second array, and then we'll see which one is smaller. Now in our case 2 is smaller. It will create, like, we'll have another array, right, a sorted one. So, or for the sake of explanation, we can say that it will eventually it will push the second element is minimum, it will push here. Now the second array is empty in our case, so it will just take this array and will push it at the end of this array. So it will take the 3 from here since we have nothing to compare it with, and it will be here. Now our I is here, our j is here. We'll compare this 2 with 5. Now we know 2 is smaller, so I will have to move here. Since we figured out that 2 is smaller, so we'll have to move our I pointer to the next element, and we will have 2 added to the array, the original. And then since 2 is also removed from here, we'll compare 3 with 5. Now 3 is smaller, obviously, so 3 will come next. And now as we see that this array has become empty, so we'll just simply move 5, meaning the whole of the second array that is left, to here. This is how we'll have this portion sorted. Similarly, to sort with this, we'll have to first sort out this. Again, with comparing 4 and 1, we know which one's smaller. We'll simply just put that here. Now we will be sorting this to the original array in the sorted form. How we're going to do it now, again, just get rid of all this stuff. Our I pointer here, our j pointer here. We'll compare 2, 1. Which one? Obviously 2 is greater than 1. So in our array here, I'll just remove all these elements because either way we're going to replace these. So now 1 is less than 2, so we'll have 1 here. Now once removed, as you see, once removed, so the j pointer will move here to this part. I won't move because we haven't removed any element from here right now. Now we'll compare 2 with 4. Obviously 2 is smaller, so 2 will be gone, added to the array. I pointer will now move because we removed an element from this array and put it back here. Now 3 and 4, 3 is smaller, so we'll add 3 here. The I pointer will move. Now 5 and 4, 4 is smaller, so 4 will come on here. Now J pointer is like, obviously now this hole is empty, so we'll just take whatever is left in the other array. When one array is empty, we take whatever is left in the other array and put it back here. So this is how we sort our arrays in merge sort. Now we have got our sorted array. Now we'll do it programmatically. Similar. Here we are back to our program. Now for that we have to create another function that has the responsibility of merging. For this we need these arguments, left, mid, as well as right. Since mid is already calculated, so we need to pass it up here for obvious reasons, right? Then just we don't forget, so I'll just add it here as well. Cool. Now first we'll have to calculate, doing it programmatically, first we have to calculate the length of the first array. Now it is calculated as mid minus left plus n. It's like basic mathematical calculations done to calculate the length of the first array, first sub array that we will have of a particular array we are merging. Okay, so we merge into an array by two sub arrays. So these two sub arrays have different lengths. They could have equal lengths. So first we have to calculate the lengths of these two arrays. Then we'll be able to merge them into the original array of the recursive call. So we'll have right minus mid value. This is how we calculate the length of the first array and the second sub array. You'll see it if you like. It's basic mathematical calculations. Then we'll just form our two arrays in which we'll push our elements. We are creating these arrays so it would be so that we can perform our merging operation on them. So now we'll populate these arrays, these empty arrays that we created with our actual values. So these are just simple looping functions. Similarly for the second array. Now when we are done populating, we have our two arrays now. Now we have to perform the merging operation. Alright, for merging operation, as we said, we'll need two pointers. But we'll need one more thing here, that will take care of our left element, because we won't always be starting from the 0th value in the array. If we are merging the right section, then we'll have other values at the start of the array other than 0, obviously. So we'll have to take care of our left values because everything would be relative to it. Now, as long as both of our arrays have values, this is what this condition means. Basically, our pointers are not extending the length. That means both of our subarrays still has their values. What we are going to do is we are going to check if the element in the left array is less than or equal to the element in the right array, and if it is, then we are going to push in our original array the left element, because we're sorting, so we need the minimum element first. And also, as we do this, as we saw on the whiteboard, we have to increment our I. We have to move our I as well if we empty an element from the left array. Else meaning obviously it means that the right value is greater, so we'll add the right value is smaller, so obviously we'll add the right value here and we'll increase j. Now after we are done with one single operation, we have to increment the k value. Why? Because this is the value that our k is basically the pointer in our original array. When we were merging, we had pointers in our merged arrays, right? Like I and j, but k is the pointer that's keeping on track on which element now is to be added at this place and this place. So we have to increment once we have added an element to the original array in which the merged output will come, we have to increment. Now once we're done this, as we know, once one of the arrays is emptied, we'll simply push the other arrays, all of the other arrays elements, because it's already sorted, since the merge function goes from bottom to top. So it's already sorted, so we'll just push all those elements to the end of the original array. So if similarly for our next array, and here we are done with our merge sort algorithm. Now we'll try running it. So let's take an array, let's take one from our examples. It was 32541. Now we'll call merge sort on it. Array, the left value is 0, and the right value, how we'll calculate it, like this. Okay, then we'll console.log a. Should do the job. Okay, we have got an error here. Oops. Alright. And yes, as you can see in our terminal, we have achieved our sorted array. Thanks for watching.